Okay, let's start things off. First of all, any questions about anything we talked about in past classes? Anything going on in the world people want to talk about? Anything? Okay. Okay. First, announcement. Several people have sent me mail about which problems are that the doublets problem cannot be graded by UVA, but can be graded by can be graded by UVA, but not programming challenges. Okay. And so one thing I've done is I've posted. I sent mail to Miguel, and he wrote back and he said, "Yeah, there are a few problems like that." He sent me a link to a list, which I think I've posted on the front page of the course. Okay? So I encourage you to check those out. Okay? And to go to the front page of the homepage of the course and see if you can find that link. And is there anybody who's got a computer? Do a quick check there. See if you can figure that out. I'll admit I posted it, but I confess I didn't check to make sure it was working. So does anybody see what I mean? If somebody can go to the home page and figure that out. First person to figure it out, raise their hands. Or no one's, the fact that no one's done it yet. Let's just check it out. So I believe if we go to here, let's look at this. I should be able to now say www.cse.ust.hk/Skiena/300. If we go to here, what I'm hoping is problems which work on UVA but not programming challenges are presented here. And boom, this gives us a link to a programming challenges page that will tell us which problems fall into that category. So we should take a look before you get too obsessed with why it's not working at programming challenges. Check if it's one of these. And we'll just verify that it comes up. Yes, so here are the problems. Not all of these are assigned. Hopefully not too many of these are assigned. But you can check that out and maybe save some frustration. Okay? Any questions? If you find any other ones that are not on this list, that I'd be very eager to find out. Any questions? Okay, so let's go through the list of problems now and see where we sit. I think this week's problems may be relatively easy compared to some of the other weeks. Okay, but let's take a look. How many people got all 4 of them done? Okay, I have 2 people with all 4. How many people got 3 of them done? 1 of them with 3 of them done. How many have 2 of them done? Okay, how many have 1 of them done? How many have none of them done? Okay, maybe the people who aren't here have none of them done. But that is a good sign. So let's take a look at these and see where we sit with this week's problems. Okay, say window, full screen, boom. First question is, who's done Where's Waldorf? Okay, is there anybody who has tried and not gotten this one working? Okay. So this is a relatively easy one. This is the one where we have to find a grid of letters. Okay, given a grid of letters and some target words. How do we find out where it is? The question I'm here interested in is how many lines long are your solutions? Okay? So someone who's got it working, people got it working, raise their hand. Some people. Okay. How long is your solution?
It's long. I have it right here.
Okay, somebody else. How long are your programs? Yes.
100 lines.
100 lines. Somebody else in the front. Yes.
Mine is like 200.
200 lines.
Because I have each direction.
Okay, well, let's take a look at that. Let's think about how long it is and whether it had to be this long. Okay? That's really the question for the day. 200, 100. What about front row? How long was yours? Ballpark figures. Somebody on that side of the room. How long was Where's Waldorf? Waldorf. You say 100? 200. Okay. Let's think about this. Okay. What in the front row? How long was yours? Feels like a text editor. Okay. So the key issue to me here is the reason why you're saying your problem. Let's remember what the problem is. And when I say that, that's to remind me. We've got a grid of letters, right? We are looking for a, what you call it, a string with the property, you have a query string, basically. And you want to figure out if in each of the 8 possible grid directions, which is the, does it match, okay? And find the first place as you scan from here, bop, 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 where it matches, right? Where the first place is defined by what? The start of the string or the end of the string? Start, okay? So it's the head. So if we had a string that went from here to here to here, the start of the string would be here. Is that right? Okay. I heard 300, 200 lines, 100 lines. How long was yours?
100.
100. Okay? What took so long? You're saying that the amount of code was mainly because you were doing...
Yeah, for each direction I had to look, I had a loop that was like, I don't know, 12 lines of code or something, and I copied that loop and pasted it.
Okay, so the first question is we did cut and paste. So one argument, the way that you did this was that there was a loop that would go from I goes from 1 to J for, I mean, basically, what you did was there was going to be a loop that says for I equals the length of the string. Match the character and find the next character, which involves adding or subtracting 1 from the X or the Y. And which way you do it, adding, subtracting 0, 1, or minus 1, depending upon which direction it is. Okay? And you did it by cutting and pasting. Okay? Now, cutting and pasting is in general a bad idea. Why is it a bad idea? You probably know, so tell me.
Took a while to debug.
Took a while to debug. Okay, so that's actually a big problem. You're saying, some people, when they say this, will say, oh, no, I can do it. I know what I'm doing. But what you're saying is the reason it took a while to debug, I suspect, is that you had to you copy each code block 8 times, and then you had to edit this to this, this to this, this to this, and at some point you made a mistake. Is that right? Okay? And when you made a mistake, you thought it was working because you just changed a number. You then submitted it and it didn't work, right? And you had to go back and say, gee, what's the problem? And that was probably very hard to debug, right? Okay, so code reuse. How many people did this by copying code? Okay, I see 1, 2, 3 people, other people admitting it. 4 people. Did you make a mistake in copying the code? No, you're saying you're good at copying code, okay? You're good at copying code. You made a mistake, or?
I made a mistake, so I need to correct all in part.
Okay, so half of you made mistakes copying code. This is one reason why copying code is a bad idea, okay? Is that it is a lot easier to copy the code than it is to get it right, okay? This is why object-oriented programming is supposed to be a big deal, right? Supposedly it avoids people from making copies. There's all kinds of horrible problems that happen in software engineering when people copy code, okay? So it's an easy temptation to fall into, but it is difficult to resist. But it is good to resist because it causes problems. So how would we have done this while avoiding the copy code? Okay, somebody who did it, okay, you.
I think their direction has some kind of rules and you can use formula to evaluate it.
Okay. You're saying, what would you say?
I think there will be some kind of formula to evaluate just because the codes are similar, just to add some.
The codes are similar, presumably except for 2 things. If you did it right, I guess. The code should be the similar except that x prime is equal to what x was plus delta x. Is that right?
Yes.
And y prime equals y plus delta y. Okay? So how would you go about do this without duplicating code?
Some kind of formula or boolean to
You
change.
say a formula or a boolean? I would have said the magic word was subroutine or function, right? What if we took as input, if we wrote it so that the way I'm thinking about doing it, and maybe you guys will have a better idea, is that I would have had a subroutine that maybe I'll call scan, that took as input perhaps the starting point, ij, where I'm looking, right? Delta x, delta y, okay? And if I'm assuming that I guess my matrix is a global thing. If not, I might tack on something from my matrix here, right?
And you also need the current word that you're looking for.
And I need the word, okay? So of these things, 3 of these are sort of global type arguments, right? I guess actually ij probably should be local, okay? But I argue everything here could be done with the exception of this, right? Does that make sense? And so I would say once you had this off in a subroutine, how could you then use this subroutine? One possibility would be that you list 8 calls to the subroutine and localize the changes to be 0, 1, 0 plus 1, minus 1. In the 8 explicit calls to the subroutine. How many people did it that way? No, 1. Another way to do it might be to have this subroutine call within 2 loops for delta x equals 0 to 1, and from minus 1 to 1. For delta y goes from minus 1 to 1. And then you're looping through what the deltas are, right? And then you could figure out, is there a match at this point, right? Does everybody see that this avoids the need for the code duplication? It even, I claim, removes the need for the explicit writing down of the 8 calls, enumerating the cases. How many people did this by enumerating the 8 cases? In one way or another. Most people. Okay, how many people did this by the loop idea? You did it with the loop over the deltas, right? Okay, which one do we think is better? Okay, who here likes better the listing the 8 cases? One person barely moving their wrist. Who here likes the loop idea better? Okay, looks like the loop idea I think is probably in principle a little bit better because it's probably less error prone. The odds that you could type out the 8 pluses or minuses correctly, okay, requires a little bit of care, okay? So in general, I would say the loop idea is probably better, okay? Any other comments about how you make this easier? Okay, yeah?
First, as to whether to use the loop idea or the enumeration idea, I think it depends on which you are dealing with. Like if you are looping through it, it's 9 grids, and you use 8 of them, so loop is a good idea. But if you're looping through the 9 grids, but you're only using 4 of them, I think you don't have to loop through them.
Well, what do you mean by why would you only use 4 of them?
Well, because I reverse the word.
Okay, I see. So one thing that you're saying is that instead of doing all 8 of these with the word, okay, you're saying that the other thing that you did was that you looked for both the word and the reversed word. This is word W and this is W reversed. Okay? And this way, if you're looking for them, which directions do you need to look? You would only need to look, I guess, this way, or this way.
I won't look forward. As I'm looking through this whole grid, I only look what I have scanned, like the upper left ones. So it's
well, wait, no. So what are the 4 directions you still have to look in? If you do it this way.
Do it. I look upper left, up, upper
You're
right.
saying upper left?
Left.
Upper left?
Yeah.
Upper left is
Yeah.
This way.
Upper left.
This way.
This way.
This way.
And upper right.
And also upper right, which is that way.
Presuming that I'm looping from top down and from left to right.
Okay. So the way that he did it is he looked for both the word and the not word. And he only looked, that would mean he'd only have to look in 8 directions. 4 directions of the 8. Okay? Does this simplify the program? To me, I don't think it does. Okay? Again, in fact, you get it working, you get points for getting it working. But why don't I think that simplifies it? First of all, there's the problem. You have to have explicit logic for, for testing whether the word is there or reversed. Because that changes whether it's the first stopping point, right? So one advantage of doing it all at once is now we could have this thing embedded in an I goes from 1 to N, J goes from 1 to N loop. And the first finding I find is going to be the right answer, right? For you, you've got to scan through the whole array anyway, it seems. Because you're not guaranteed that just because you found, let's say I find a solution here, if it's a reverse, then in fact the head goes down here and there's got to be an earlier head. There might be an earlier head, right?
Because I'm not scanning through the whole string of the word. And I just look at what I've scanned before. And it's kind of inference.
Okay, so you're saying it's inference. I still think this logic is more complicated than it has to be. That's my belief. But your program is what it is, right? Do you think the logic, do you like this way of doing it, or do you think the logic is too complicated? More excessively complicated. You're saying it's not complicated to you, okay? It seems complicated to me. More complicated it has to for me. That's my belief. But
basically, no, the basic idea is I'm using KMP pattern match.
Okay, so what you seem to be worried about is you're trying to be very efficient. Is that right?
Yeah.
Okay, you're trying to minimize the use of the computer time. And that is the wrong thing, I would claim, for you to be doing at this point. Okay? Why? Because your idea of computer time is, so long as it runs fast enough, then it's fast enough, right? And here, I don't think that any way you do it, it's basically going to be something like linear. Here's one where I don't think that there is a performance issue, a runtime performance issue. And if there's not going to be a runtime performance issue, it's not worth making an algorithmic performance issue about it. Do you agree with that? Okay, any questions? Actually, I'm a little bit curious about the KMP use that you're talking about. Does anyone know, who here knows what he means by KMP? One other person. Who here doesn't know what he means by KMP? Okay, so one thing that's interesting is there is a generally important algorithm problem of how do you find a substring in a string? Okay? So let's go back to this for a second. In fact, I had this slide in here. The simplest, let's say, interesting string algorithm, or let's say one of the first interesting string problems, is that of substring pattern matching. Okay? Where I give you as input, you have a text string, and I give you a pattern string. And I ask you, let's say the pattern string is, have. And I give you a text string. And you want to find where is the first place in the text where the pattern exists as a sequence of consecutive characters. This is string matching. Okay? If you had to do string matching, where I gave you as input a text and I gave you a pattern string, how would you go about doing it? What is the easiest way to go and do string matching? You say check word by word. I would first say there's an even simpler way than checking word by word. What?
Letter by letter.
What? Letter by letter, I'd say there's an even simpler way of doing it, which is called the library function. Does everybody see that? Okay. So the first simplest way of doing this is to call a library function. So in your favorite programming language, which here seems to be C/C++, what is the language? Is there a library function that, given a pattern and given a text, will search for it? Substring, right? How do we call that? In C, what is that? Well, first of all, what? Sub-str. Is that right? In C++, is there a way of doing it? What is the right way to do that in C++? What? Does anybody ever know what that object, the string object is? Do I have it here? I may even have it written down here for all I know. Okay, substring here among the C libraries. Sure enough, string copy. Actually, I don't seem to have string. What?
str.
str. Okay. So that's actually the library function here.
But substring is sub-str is for C++.
What?
Sub-str is for C++.
So you're saying a sub-str is a C++ function. Let's see if that's right.
Sub-str is not fine. It's not fine.
Okay, well, let's say it's find the answer. Find looks like to me that's the answer, right? So the simplest way of doing it is the find method. Does everybody agree with that? Okay? Now, let's say you're not allowed to use it. What is...
I think find function is find the character, not the string.
No, I think find method is you give it as input. These are methods operating on a string. Find s means give it another caret string. Find the first left position, occurrence of that to the leftmost, right? Does everybody agree with that? So I would argue that the simplest way to solve this problem would be with find. Okay? Now, how does find work? That's maybe the question we were originally getting at. Is now, how would you go about now implementing a function? Suppose I now ask you to implement find. What is the right way to do it? Okay? And basically the idea that I heard, or the obvious idea, is basically to take the text, put the pattern starting at the first position, keep scanning so long as they match. Let's say the sentence was half, half instead of have. I would check half H to H, yes, that matches. A to A, yes, that matches. V to L, that does not match. So the pattern cannot match from the first position. Slide the pattern over by one position, to put it in the second position, and then explicitly test. Does everybody see what that algorithm is? How many people see what I'm talking about? Okay? What is the algorithmic reply? Here's, in fact, my implementation of it. What did I do? Find the length of the pattern, the length of the text. For each possible starting position in the text, okay, let J be a counter saying, where in the pattern am I? Match the I plus jth character of the text against the ith character of the jth character of the pattern. If they keep matching, keep looping. The moment there is a mismatch, okay, bomb out and increment this counter. Okay? If I make it to the end of this loop, then in fact I have found the string at the ith position. Any questions about that? What is the runtime complexity of this method? Okay, this will eventually get us back to KMP. If this string was of length n and this string was of length m, what is the runtime complexity of that? N times n. Does everybody see that? Now, is that good or bad? Okay, the answer is not too bad. Depends upon what your situation is. Okay? If you're looking for a person's name in the Bible, let's take a look at that. That's what I think of as an example. The Bible is, if you want to say a Skiena in the Bible, okay? The Bible is a long string. Let's say 10 million letters. Skiena, though, is a very short string. Does everybody see that? So if one of the strings is short, is constant size, this is still going to be linear, right? This is only expensive if both of the strings are long. That's when it gets to be a problem. Does everybody see that? Even if both strings are long, is this necessarily a problem? When might this run fast, even if both strings were long? Yeah?
When it keeps finding out that it's not a pattern quickly, or like in the beginning of the search.
Note that this one over here tests a pattern, overlays a pattern onto the string, and doesn't look for the full length of the pattern. It looks for the first mismatch. Does everybody see that? So unless you've got a pathological strings here, if this string does not occur in the text, okay, it will probably find a mismatch pretty quickly, right? And even then, it's going to go back there. So suppose, let's say this was the Bible, and my pattern was the Declaration of Independence. Well, you knows what the Declaration of Independence is. It's another English language document. It's an American document, so you shouldn't necessarily know what it is. But it's clear that the Declaration of Independence will not be in. It's a long document, but it's not going to occur as a substring of the Bible, right? It is probably going to get rejected pretty quickly. And even though this could be quadratic, it probably won't be, unless the strings are bad. Can anybody give me a text and a pattern where this algorithm is going to really do badly? The pattern doesn't exist, but it's going to take a long time? Yeah?
Where the long string that you're looking in is like all one letter, like all V's or something.
Okay, what if these things are all, what did you say?
V.
V, 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 V.
And the substring you're looking for is a lot of V's with the W on the end.
What if we have, the pattern was V, 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 W. Okay? In this case, what's going to happen? Aligning the text to the pattern and match, 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 oops. Shift it over, match, 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 oops. Does everybody agree? That one will be quadratic. Okay? And that's the bad problem. Okay? Now, he said KMP. He mumbled the letters KMP. What does KMP mean? Okay? It turns out that there is a smarter string matching algorithm than explicitly matching the text, the pattern, start the pattern in each place. Okay? How might we be smarter, let's say, in the case of, let's say that we did match this world, where the text were all V's, our pattern matched V, 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 W. Okay? How far can we slide the pattern over? Okay? One thing to note, there are a couple clues we have that mean we can slide the pattern more than one position. One of the fact is that we know that this position in the text is not a W. Is that agreed? Because it rejected here. And it knew that none of these positions, okay, so what did we know here? There are a couple of things that we would know. One is that because all of these are V's matched, okay, if we shift the pattern over one spot, V, 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 W, there is no reason to do these comparisons again. Does everybody see that idea? Because in principle we know that those are V's because we know what the pattern was. If we're smart enough, we don't have to actually do those comparisons. And the Knuth-Morris-Pratt algorithm, the KMP algorithm, is smart enough to avoid doing that thing. Okay? So the good news is that there is a faster algorithm than the quadratic one. It's not that long, but it's tricky. What's the easiest way to get the Knuth-Morris-Pratt algorithm implemented? Did you implement it?
Yeah.
What's the easiest way to get it implemented?
I say for each character of the pattern to be matched, the pre-matched one, that is.
Okay, so you implemented it yourself. My feeling would be, if I was Mr. C++, okay, and I had implemented this object, he is the guy who should be implementing the Knuth-Morris-Pratt algorithm, right? This is an important thing that a lot of people are using. This should be a fast search, right? It is probably the case that for your problem in this thing, I see no reason why you need a fast searching algorithm. Okay? Because the naive one is presumably going to work fast enough. Okay? And so, I mean, maybe you implemented it because you're interested. Did you implement it because you're interested? Or did you implement it because you really thought it needed to be that fast?
I'm interested and I want to practice it.
Okay, so if you're implemented and you want to practice it, that's a reason to do it. For the purposes of getting the problem done, that is not a reason to do it. Does everybody understand that? This is an important thing about not trying, this is part of the KISS philosophy, of keeping it simple, okay, unless you need to do it. Okay? Any questions? Okay? Any other questions? How did people do the test to bunk off, about whether they bunked off the end of the array? Okay? Because at some point, if you're searching from here, and you're walking in that direction, you go off the end of the array, and you've got to terminate your search. How did people do it? How many people did this with explicit index checks? Okay, 1. How many people did this by making the array fatter and putting a weird character in here, which was guaranteed to fail? Okay, a bunch of people. Okay? I think this is probably the easier way to do it, right? To look at a character that isn't going to be in any of the strings. Did they tell you that all the strings were really text made out of letters? And there was no punctuation or anything like that? So you could have built an array. 4i goes from from 1 to n. 1j goes from 1 to n. Initialize it to nulls. Okay, or initialize it to asterisks. Then write in the right array here. Okay? And you wouldn't need to check the indexes. Any questions? Okay? So these go into making the problem shorter. Any other issues with this problem before I beat it to death? Okay? I might very well have beat it to death now. But I think it's good to talk through the simple ones to see if we can find better ways to do them. Any questions? Okay. Next one. Crypt kicker. How many people did crypt kicker? Got that working. Okay, what was crypt kicker? Someone just remind us. Yes.
Just decrypt the text and the text contains special sentence.
Okay, so the idea here is that you were given as input. Where do I have my pens here? With this one, we were given as input a bunch of sentences. One of which was an encoded version of the quick brown fox jumped over the lazy dog, right? We had to figure out which one that one was and then use that to define a substitution cipher for it, right? How did you figure out which sentence it was? Okay, someone who got it. How did they figure out which sentence it was? Yes.
Check the first check the whole link. If the link is not matched, then next one, and check one by one. First one encrypt it as T, second one encrypt as H, and check whether it is encrypted before. Okay.
So what you did is first check to see if the sentence was the right length. Okay. And then what you did was what?
Check the letter one by one.
Check the letters one by one, and what you would do is you would take this version, instead of the, it was A, B, C. Okay? You said A goes to T, right?
And B goes to H.
B goes to A, C goes to this thing. How would you know whether or not there was a conflict? It made a mistake.
I first check whether the letter is encrypted before.
Right, so you initialize, you had basically a mapping from A to Z, initially set to be, let's say, all asterisks, right? Okay?
And if it's not included before, or it is encrypted.
If it is not included before, you set it to be, like A became the T. If later on you saw another A, and you need it to be a Q, if it was a non-null, okay, and it wasn't the same thing, you knew that you had a mistake, right? Does everybody see that? That sounds like a reasonable way to do it. Okay? How many lines long was your program?
40-something.
40-something. How many people, who had other solutions? Who else had solutions to it? Have had solutions to Crypt Kicker? Somebody, I know you had to. Some people got 4, so some other people. How long was yours?
Oh, so many, hundreds.
You had hundreds of
Yeah,
this.
because I hard code.
You what?
I get a hard code to solve this problem because I compare each word, each letter, the whole sentence, and compare it one by one. I hope hard code it because we about 20-something letters in that line. The fourth that line. So I hard code it. So I make a long program.
Wait, what did you do? This is weird to me.
What?
What did you do? This is a weird thing to me. Say this again.
Just hard code because.
What do you mean by hard coded? You.
Or measure the letters one by one. Measure the quick brown force
Yeah.
in the dictionary one by one. Measure each letter one by one. Measure this sentence.
Okay. Well, wait, no. So what is the data structure used to represent the input sentence?
What?
Okay, I'm not quite understanding this yet. Okay? So, did you have... First of all, how did you represent the input sentence, the quick brown fox?
Just character array for 26 letters.
You had an array of 26 by what?
No, yeah, and then measure this sentence one by letter.
Wait, you tried all 26 factorial letter
That's right,
permutations? No.
Just first, like him compare the sentence length, and then compare the words length.
Okay.
And then compare each word one by one by hand.
By hand.
Yeah. For example, this sentence, the quick brown force, like the 5th letter is equal to the 10th letter. It's O, so I compare it. If the sentence is like that, so I will measure it.
So you did this by hard-coded logic?
Yeah.
If statements in your program?
What?
Did you do this by if statements?
Yeah.
Okay, so you're saying there's a long chain of if statements that you had for code here. Okay, this is a ghastly thing to do. Okay? How many lines long was your program?
100.
Hundreds. Okay, this is a horrible thing for a couple of reasons. First of all, it's obviously a lot more work. And second of all, I'm amazed you got it right. Because undoubtedly you didn't get it right. Maybe they didn't have enough test cases to fool you, to catch you. But the odds that you actually encoded all the constraints seems to me to be probably pretty hard. Okay? So that's not a good thing to do. Okay? It seems to me. Okay? How would I have done this? Okay, or how might we have done this? Okay? We need a way to encode the original sentence. How would you have encoded the original sentence? How did you do that? How did you get the sentence, the quick brown fox into the lady dog, into your program?
Just a constant string.
You used a constant string. Does everybody see what that means? Does everybody know, this is a dumb question perhaps, does everybody know how to initialize a string constant? Who here knows how to initialize a string constant? Who here does not know how to initialize a string constant? At least one person, okay? Come and show us how to do it. Go ahead, try this.
Quick bond forest.
Okay, so does everybody see what he did now? He set up a character array string at the top of this program, str, and he initialized it to quotes with the contents of the string in it. And that's a way that you can initialize the string. Okay, without needing hard-coded logic, without trying to read it from someplace, right? Without having a char 1 equals t, char 2 equals h, char 3 equals that. Does everybody see it? In one simple string constant, you can load it. Okay? How did you represent the array of the encoded strings? What did you do to get in all the encoded strings? Did you read them once, or did you read them many times?
I just read it one time and store it in a string array, and then try to match the sentence and then convert it then outward.
Okay. So the idea, did you do that?
I don't quite get it.
How did you store the array of strings? Did you store explicitly read in all the sentences that were encrypted?
Oh yeah, I read it all.
Is there anybody who tried to do something like read it and then reset the file and then go back and read it again? Is there anybody who tried to do something horrible like that? No. Okay, so that's good. This is one where, yes, I would say you read the sentence. Okay? Then now what you would want to do, basically, it seems to me, is now test. For I goes to the number of sentences. I goes from 1 to the number of sentences. Right? You want to ask, is I, sentence of I, is that going to be equal to the string? Okay? And I think that the basic test of how to do it is what you were suggesting, right? Any questions? Yes.
I'm quite not understand. Is this technique need back tackling?
Is this what?
This problem need back tackling.
Does this problem need backtracking? Okay. I see no reason why it needs backtracking.
Or maybe I don't understand what the problem is.
Okay, so what is the problem? The problem was you were given as input several different sentences, all of which are encrypted.
But are all the sentences with distinct length?
No, they may not be distinct length. They may all be the same sentence even. Okay? It could be the quick brown fox. There could be an alternate encoding of it. There's no rule law. It even has to make sense to be an English word, really, right? They could, in fact, give you the quick brown fox jumped over the lazy dog and then give you another encoding with the same pattern, right? So the important thing was you were allowed to use any pattern sentence of the right template, right? That's what they said in here. Is that right? Did they say if there were two sentences that matched, you could use any of them? Okay. So the basic way that I think I would do it is for I goes from 1 to the number of sentences. Test whether the ith sentence is compatible with the quick brown fox jumped over the lazy dog. If it is, I now have my encoding. And now then, I would bomb out to a second loop that uses my encoding table and re-encodes all the sentences. Yeah?
Do we have to think about the fact that there might be a sentence with the exact same pattern as the quick brown fox that wasn't actually?
Well, do we need to think about it? Let's look at the problem statement and see if we need to think about it. That's, I guess, the way question of how do you need to worry about that? Do I have one of these things? How do we go about this thing? What was it? Where do I have to find it? Programmingchallenges.com. That's to sign on. Let's look at the wording of what we actually have. Is this going to be it? Log in? How come I can't log in? Firefox. Okay, boom. Let's get rid of this. Let's just see if we can get the program here. Boom. Turns out if, oh, actually the truth is we're missing an S, actually. You also think we need a hyphen? At one point we did. I think we had both domains, but he may have lost both the domain. Okay. Oh, I'm missing the double. Okay, just to be obnoxious, I'm going to get rid of the quote and then put in a double. Okay.
And also the hyphen.
See, the hyphen I didn't need. Okay, that's I guess what I was trying to show you. But let's come back here. Oh no, Skiena is here. Sorry about that. Let's just go here. Okay, so which problems are we looking at? 3. Crypt kicker 2. Let's look at this. So a legitimate question would be, what happens when there are multiple sentences of the same pattern? What in this write-up tells us the answer to that? Does anybody see where in the write-up that the answer to that question is resolved? Output?
There is more than one possible description.
Says here, if there is more than one possible description, any one will do. Okay? So that's the interesting thing here. Okay? Is that in this case there is no need to, if there are more than one answers, this is how they resolve it. They let you do anything. And the reason the judge can get, why can the judge get away with that, by the way? Okay? How would the judge tell whether your program is right when there might be multiple solutions? Okay?
There's a checker problem.
What? There's a checker problem. This is why Programming Challenges judge probably has a trouble with it. But I would imagine that it's probably enough for their judge just to check that you get no solution when there is no solution. Does everybody agree with that? That would be probably the easy way to check it. Okay? To see if you know what you're doing. Okay? Any other questions about this problem? Okay? I think this problem brings up some interesting issues. If you do it right, you said yours was 40 lines long. This is good. This beats what this is. Okay? And you should learn your lesson about something. Okay? Any other questions or comments about how people did it? Okay? That's fine. What is the next problem? The next problem was file fragmentation. How many people got file fragmentation? How many people have not got file fragmentation? Who tried it? Okay, anybody who tried it, who couldn't get it? Okay? What is the problem? Tell me what the problem is. And then what's the story with your program?
Well, every time I try to
What's the problem? Let's make sure we know remind us what the problem is.
the problem is your friend in job
Okay, forget about the friend. Let's talk about it now in terms of input and output. Okay.
the input is a lot of file that is broken into small pieces. What you're trying to do is try to put it back into one single piece.
Okay. So the interesting thing here is you're given 2 times n fragments. Is that right? Where there were n copies of the same word, right? And your question was to try to figure out what that word would be. Okay? How did you go about doing it?
Well, every time I try to match every single of them. So that if the second is longer than the first one, I will use the second. And I try to match, if it's shorter than that, I try to match it inside. If it's not inside, I try to add it in the front line, and in the end.
Okay, wait. So first of all, the question is, You took the first string and you wanted to find out which is the mate of this one, right? And did you check it against all of the other ones?
I just changed at the end of the second. The
You
one
ch-
next to it.
You take this one against the one next to it. Okay? Why is it going to be the one next to it? Why can't it be, it may be this one?
Well, I tried it from the start. First one, I think, because what I think is, if that's not the same for the second one, it won't be the same for the last one as well.
Okay? I don't understand your logic here. I don't think it's right. Okay? Any other ideas as to how you would do this one? Yes, you.
We can put the fragments of different lengths in different arrays.
So what you did was you put fragments of different length into different arrays, okay?
And try to add all the lengths up and divide by the half of the total number of fragments, so you can know the file length.
Okay, so the first question is, could you figure out the length of the file length? And this I claim you could do pretty easily. How do you find the length of the file length? How do you find the file length? Since every string is represented by both halves, you sum up the length of the strings and you divide by 2n, basically, right? 2, and gives you n, right? Okay, now that you know the length, you want to try to find out what the mate pair is. How many strings of length 3 might there be in the input? Okay? You said you sorted the strings so that the ones of the same length appear next to each other. Or how many strings of length 3 could there be in this input? Only 2. Why only 2? Because we know that every string was broken into a head and a tail. Does everybody see that? So either the head is of length 3 or the tail is of length 3, and those are your only choices, right? So what's interesting then, I guess, is now you know that for any string, you know it's got at most 2 partners, right? And if it's at most 2 partners, it could either be at the beginning forward or reversed. Does everybody see that? There's two orders for the partners. So one possibility is you construct them and then you test them. Is that right? How do you test if a string is consistent with your input? Okay. Yeah?
I just have the same idea with him because I've sorted by array the file size.
Okay.
In an array. For example, I know the file length is n. Okay, one file length is n. For one input is, for example, m length. The other file is n minus.
Right. Okay. So you can take a look. I agree. You've now got the biggest and the smallest. Here there's 2 biggest and here there's 2 smallest. Now what do you do?
Then measure and try the file recursion. Try.
What?
I'm idea that the shortest string must be a substring of half of the other strings.
You're saying that the shortest string must be a substring of half the other strings.
Either from the first letter or the last letter, so you can decide whether it's the start of the end and keep recursively do for each string.
Is that useful? Okay. I don't see where that, what you're saying is it's true that the shortest string is going to have to be a substring of at least n of the strings.
Yeah, so I can know if the shortest string is it's the start of the 5 or the end of 5.
It may not be true.
I don't think that that's necessarily true. Okay, I don't understand that logic here.
I can do the recursively. Of course, if the first shortest string is not, it has a second shortest string until all the come.
Okay,
But the
that may be complicated, but I don't know that.
this method cannot keep all the things.
What?
But this method cannot judge all the case because if the 0 and 1 have the same number, you can't judge it by this method.
Right, yeah, so I don't believe that your method is sufficient. Okay? How did you do it?
I didn't do it.
You didn't do it, okay. How do we test this thing? Okay? The real problem that I'm now seeing is a question of validation. I get your ideas now that you're going to take a look at the shortest and the longest. There's going to be at most two shortest ones, A and B. There's going to be at most two longest ones, C and D. How many strings are there that are possible then, given this information? Okay? It seems to me that you have to choose one of the strings is going to be, you have to choose how many pairs, let's say, how many possible strings are there? You say 4? Which are the 4 possibilities?
AC, AD,
AC, AD,
no, 8.
8,
8 combinations, yeah.
BC,
BC, BD,
BD,
yeah, and then
CA,
yeah.
CB, DA, DB. Okay? So there's 8 possible strings. Now, how do you tell which one of these is right? That's really now the more interesting question. Right? How could we tell if that's right? Okay? Any ideas how now, once you've got a string, you could tell how it's right? Which one is right? Okay? Yeah?
You'd have to see if it's possible to match up the other ones the same way.
So one possibility is that you, for every one of these strings, you would now figure out, is there a way to match it up? Okay? So what you're really saying here, I think, is that just like there was 8 possible interpretations of this pair, right? There's 8 possible interpretations of every other pair ordered by length. Does everybody agree with that? Here we did the longest and the shortest. We also have the mid-range ones, right? And what you really would need to tell now, it seems to me, is for any one of these strings, is it compatible with every other pairing? That seems to me to be the condition that's necessary. Did anybody, who did this one and got it past the judge? Okay, how did you do it?
Actually, I did it
Long time ago, so you're cheating. Okay, fine. No problem, no problem.
Just some stupid method and check.
Okay, some stupid method we don't like. Okay, is there anything clever to be done here?
I remember that the test case is quite weak. I think my algorithm is wrong, but I passed the judge.
Okay, that's an inspiring story. Okay? Anybody have a correct algorithm? I think that what we're talking about, there's a correct way to do it that's not that hard, based on what we said, basically, right? For each of the 8 possibilities. Check. Now you've got a string. The real question is this string compatible with, okay, each of the other 8 possibilities based by length? Okay? That's how I would think about doing it. Okay? Any other ideas? Anybody who got it working, tell me how long your program is. Very long. I don't want to look at your program today, this week. Anybody else have it working? Okay, let's see what you can do. I claim if you think about this right, it's now reduced to a finite case. Now let's try to see how clever we can be about making that happen. Any questions? Okay. Let's go back here. What about doublets? That was the last one. We're not doing FMT. I changed it on the judge so everybody knows. Doublets. Okay. Who's worked on the doublets problem? Okay. What is the doublets problem?
It's about
a list of words, so you can change your word by moving. So you are going to, given two words, you are going to find the path from movement to another word.
Okay, so the answer is you're given a dictionary. The problem is you're given a dictionary, you're given a start word and an end word, and you have to figure out, is there a word ladder where you go from one word to the other, one letter to the other, okay? From one word to the other by using a chain of words with one character substitutions. Okay? If I remember correct, the guy who invented these kind of puzzles was Lewis Carroll. Does anyone know who Lewis Carroll was? Okay? Again, this may be a cultural thing. Who knows who Lewis Carroll was? Okay, his real name was Charles Dodson. Who knows who Charles Dodson was? The answer is Lewis Carroll. Okay, Lewis Carroll was the mathematician who wrote Alice in Wonderland. Did anybody ever, who here's ever read, a kid read the story Alice in Wonderland? Okay,
Mathematician.
American. He was a mathematician by training, actually. Okay, he's actually a logician, to be precise. Okay, any questions? So how do we go about doing this? Okay, is any word ladder between two of them acceptable? How do we deal with duplicates here? What is the word ladder that we report? Is it any word ladder that goes from here to there? Or is there any special qualifications on the ladder that we give? Is there any special properties or something like that that ladder has to have?
In the dictionary.
Every word has to be, this has to be, follow it, each word has to be in the dictionary, that much we agree. They've got to differ by one letter from each other. Is there, sorry about this. Is there anything about consecutive, is there anything about, are all solutions paths that go from this to this equally acceptable?
Shortest.
You say it needs to be shortest. Okay? That means using the smallest number of changes. Are all shortest ones equally good? Okay, let's look at that. That would be a potential problem. It says here, if there are several minimal solutions, any one will do. Okay? Does everybody see that? Okay? So now I understand the problem. How do we go about doing it? Let's think about this. Okay? What do we have to do with this problem? What? DFS. But when I say DFS, DFS is a problem on graphs. This is a problem on strings, right? So what is the connection between graphs and strings here? Build a graph. What are the graphs have vertices and edges? What is the graph? What are the vertices of the graph?
The words and the edges means that the two words moving
The vertices are an edge, and there is an edge. The vertices represent strings, and right there's a vertex that represents each string. There is an edge from one string to another if what?
If they are Doublets.
If they differ by two one letter, right? Now, is this a directed graph or an undirected graph? Undirected graph, right? Because an edge from here to there means an edge from there to there, right? So this is an undirected graph. And then what do we want to do with our graph? Okay? The basic problem is what? You say DFS. What does DFS mean?
That first search means I want to do the search from the first letter to the destiny.
But why don't we use breadth?
You want to start from this vertex and you want to end up here. People are saying use breadth first search instead of depth first search.
Breadth first search requires a key and
He's saying breadth first search requires a queue. He doesn't want to do breadth first search because he doesn't want to get a queue. Why do you want to do breadth first search?
Because shortest path is guaranteed.
Yeah, because if you use depth first search, you get the wrong answer. That's why I think you like breadth first search.
Skiena solution.
So it's a question of here, we need to find the shortest path. Yes?
I think A star is more fast because it's very easy to more easy to
Okay, well let's think what we have here. Okay, so let's think what we're dealing with. Okay? You couldn't do depth first search because depth first search, let's say this was the graph. And it had other edges, but kabunk, kabunk, kabunk. Depth first search would have been perfectly happy finding this. Does everybody agree with that? So depth first search is verboten. That's not right. Breadth first search in an unweighted graph is right. Okay, so that I accept. Now you're telling me you have A star,
My
but
story is that I already sent you an email. I got EC UVA, but I got .A.
okay, so you got accepted by UVA and that counts. This one, the judge does not work right for programming challenges. Okay, so that's life. But let's get back to A star for a minute. What was this A star business?
A star just like a BFS but add a heuristic function to calculate the
What kind of heuristic in this role?
The heuristic function is calculate the mismatched words. How many mismatched words is the minimum path? So you can use it as a heuristic function and calculate
Okay.
the path.
So what he's saying now, if I'm going to interpret, how many people here know what A star is? Raise your hand if you know what A star is. Raise your hand if you don't know what A star is. Okay? I don't use A star very much, if anything. So my definition now may be a little bit fuzzy. But what A star is not a breadth first search, as I look at it, is a walk all the nodes at distance 1, then all the nodes at distance 2. That's BFS, right? Depth first search is lurch as far as you can, discovering things, and then back up, right? That's DFS. A star is a best first search, not breadth first search. A star is best first search. Okay? Okay? And so in an A star one, okay, that's best first search. What does that mean? That means that basically what he's going to do, if I understand you correct, here's your target. Here is your starting point. You would find which word is it that moves me closest to my target. Okay? And start walking in that direction. And then walk in the next one that moves me closer and closer and closer. And maybe I'm going to have to backtrack at some point, because I'm no longer closer. And then eventually I'm going to find the path to this word. Right? That's what A star is going to do. The trouble, of course, with A star is that the first time you find a word, that path is not necessarily the shortest path of all.
A star is make sure the answer you find is the minimum. A star can make sure.
A star is admissible if your heuristic is
Yeah.
Right, so then in order to make sure you find the right thing, you've got to deal with lower bounds. Right? And stuff like that. Okay? So A star is potentially good if there is a large search space and you want to find a value quickly. Now, in this particular problem, is there a large search space? The answer is no. Okay? How big is this graph? It's got how many vertices? It's got 25K vertices. Does everybody see that? How many edges does it have? How many edges can go out of any one vertex? Okay?
About 400 or something.
You say about 400. Why is it? 400.
Number of A to Z time number of maximum length.
It's the number of characters in the string, which is how much? How big? What's the longest word in the dictionary?
At most 16.
16. And it represents that for each one it's changing one letter to something else, right? Certainly an upper bound on the number of edges would be 16 times 26. Does everybody see that? Because there's only 16 possible positions and 26 things you can change it to. Right? Is that about 400?
416.
You said what?
416.
Is that 460 if you multiply that together?
16 maybe.
Probably only need 25 because it has to be a different letter. Right?
400.
This is more than 400, right?
This is exactly 400.
That's 400?
Yeah.
You're right, that's exactly 400. Okay, good. Okay, 16 times 25 is indeed 400. Good answer. Okay? So, is this graph too big to do a breadth first search on? And I see no reason why not. Breadth first search is linear in the size of the graph, right? Does everybody agree with that? How many edges are there in this thing? There's 25,000 times 400. What is 25,000 times 400? 10 million? So in the biggest thing, that starts to maybe be, you know, a marginal thing. But I still believe this could be done by depth breadth first search without any real problems. I don't think there's a time issue here. Okay? Any questions? Okay? How did you represent the graph? Those of you who did it. How do you represent the graph here?
I use array of character array and vector of image to present it.
So the question is, are you representing the graph explicitly or implicitly? This is the question I want to ask. Explicitly would mean that you have vertices and you have edges. The other possibility is that you represent it implicitly, where you just have basically an array of strings, and when you want to find out what are the strings that are at distance 1 from this, you explicitly search through to find out all the neighbors of it. Okay? Who here built the graph in advance and then did BFS? You did.
You did the graph first and then.
Then you did your thing. Okay? Who kept the graph as an implicit structure? You did. Okay? Where you logically did a breadth first search. Right?
I first sort the string alphabetically and then do binary search.
So what you did is, in order to find out what edges there were, you sorted the strings alphabetically. So you could do binary search on them, right? And then for every string here, to find out what its neighbors are, you checked the 400 possibilities. And you did 400 binary searches to find the neighborhoods of it. Does everybody see that? So he started out with one word as his starting point. He had a flat bit of some flags probably to say whether or not this vertex has been completely explored yet, right? So we don't put it on the queue again, right? And then what he would do is say, for all my neighbors here, what am I going to do? I'm going to construct all the 400 possibilities. Do a binary search for it. Okay? Then, once I know that, come back and deal with it. Okay? That sounds pretty reasonable to me. Okay? Any other ideas as to how you might improve that or not improve that? Okay? One question is, did you need to were there hash tables that you had? Are hash tables built into C? If you used STL, did you implement your own binary search?
Yeah, I had written my program in C, so.
Okay, so he wrote his program in C. First thing you said, you wrote your own binary search, right? That's a bad thing for a couple of reasons. One is there is a binary search written in C. Does everybody know that? Q-sort. Q-sort is the quicksort algorithm, right? You know about Q-sort, right? Q-sort has a brother function called B-search.
Oh, yes, I remember.
Okay? So the first question is, you didn't have to write your own binary search, right? Okay? And binary search is a tricky algorithm. Supposedly, binary search was invented, back in 1945 by when people started doing, in the early days of computers, right? Very early days. On the other hand, someone once did a study and they found that the first correct published version of binary search wasn't published till 1962. Okay? That there are subtleties with your binary search. Binary search tends to be something that often people make mistakes with. Did yours work the first time?
Not really.
Okay, so bingo, okay? So you're no better than the people in 1945, right? Okay? Binary search is a tricky thing. Okay? It doesn't sound tricky. Nothing sounds tricky till you try to implement it. The best way to do it would be to use somebody else's. Okay? That's why God invented libraries, right? Okay? What else, if you use C++, what could you use?
Lower bound.
Lower bound? I don't know about that. How might you have maintained this dictionary here? If you used STL, what would be the right way to maintain this dictionary? His job that he's looking for, he's repeatedly saying, here's a list of words. Here is a candidate. Is this word in my list? That's the question you're asking, right? So how would you go about doing that using STL? What's the easiest data structure for that?
Only vectors.
Vectors is okay. Is vectors the equivalent of a hash table?
No hash table. You just sort it, right?
But then we can use a set.
Sets, I think, are exactly what we're dealing with here, right? I mean, somehow there's the functional equivalent of a hash table, I suspect, in STL, right? I think set is the answer there, okay, but I'm not sure. But I would argue that using the right STL data structure, this would become a trivial matter to maintain the dictionary, okay? I kind of like this implicit approach, in this case, better than the explicit approach, okay? Any questions? Any other approaches or ideas here with these? Okay? So I think this has been a good discussion. Okay? Any other questions or comments about any of these problems? Anything people found interesting, not interesting? Anything like that? One question now. Suppose I wanted to change my problem. Suppose I now tell you that doublets didn't want the shortest ladder, but it wanted the longest ladder. Okay? How would you do the longest ladder? Okay? Let's think about this for a minute.
If you can ever reach it, the longest will be infinity.
You're saying the longest would be infinite because you could bop back and forth, roaster, toaster, roaster, toaster, roaster, toaster, right?
Yes.
Okay? Let's say I wanted the longest simple one, meaning one that doesn't allow a word to be repeated. Okay? How would I go and find that? Any ideas?
Exhaustion.
Exhaustion. Exhaustive search is what he's proposing, right? Any better ideas? Okay? Actually, there are no better ideas for this problem. Okay? This problem of finding the longest path in a graph, that's NP-complete, right? What problem that you know is NP-complete is like finding the longest path in a graph? Is there a name for that you've heard of?
TSP.
TSP, Hamiltonian cycle, these kind of things, right? They have to do with finding the thing that visits the most vertices without repeating. Okay? So in fact, if they ask for the longest one, you'd be in trouble. You'd have to do exhaustive search. Okay? Shortest one, we can get away with BFS. Okay? And I would say A star is overkill. Okay? Any questions? Okay? Any questions? Okay. Beat on it. Good luck. And we'll talk about the next set of problems on Monday. Okay. Thank you.